Okay, the next thing we want to be able to do in parametric form is find the arc length. So remember, basically, arc length is if I give you a curve of anything, I'm looking for the length from one end to the other. Now, recall back in function form, your arc length is this, square root of 1 plus the derivative squared. So this was your arc length formula when it was given in function form, so y in terms of x. In parametric form, it's very similar. You're still going to be integrating. You're adding up a whole bunch of pieces, square root of, but this rewritten in parametric is really dx dt squared plus dy dt squared. And most of these problems we'll be doing with your calculator. You just have to be able to do the setup. So arc length for these two functions is going to be, I'm going to be integrating from -1 to 1, square root of dx dt, which is 2t squared, plus dy dt, which is 12t squared squared. And in terms of dt, just go ahead and integrate that on your calculator and check that this is the value that you get. Now, when you type this in your calculator, you only want to be in parametric mode to actually look at the graph, but once you start doing the integration, notice there's only one variable here. It happens to be t, so you will type this into y1 and just use x as your t and just integrate it in function mode like we've done before. Part B, so we're going to integrate from 1 to 2, square root of, your dx dt in this problem is 1/2 t to the -1/2, so t to the -1/2 squared, plus dy dt is going to be 3 squared dt, and if you integrate on your calculator, you should get 3.029.